A 32.5 gram block of iron is initially at 22.7 degrees Celsius. It is then placed in a beaker of water, initially at a temperature of 63.2. Upon reaching thermal equilibrium, the final temperature of the mixture is 59.5 degrees Celsius. What is the mass of water in the beaker? So looking at this problem, the first step is to identify our givens. Well, we initially have the mass of iron as 32.5, temperature initial iron is 22.7. Then we have the initial temperature of the water. So that labeling is extremely important. Again, this is TI for water, and this is 63.2 degrees Celsius. Finally, here's where the theory comes into play. It says the temperature of the mixture is 59.5. So even if they didn't explicitly state this, we anticipate that the metal block in the water reach thermal equilibrium. So whenever we have two objects in contact, we expect the heat, the transfer of thermal energy, to occur from the higher temperature object to the lower temperature object. Heat is always transferred from hot to cold. So when this energy exchange occurs, yeah, it's driven by a temperature change. A difference in temperature drives the transfer of thermal energy. Again, the transfer of heat or thermal energy is driven by a temperature difference. So this spontaneously occurs. Okay, so if this occurs, then this means that both temperatures of our objects, our metal, our iron block, and our water should reach, yeah, everything should even out and it should become an equal temperature. When this occurs, it's called thermal equilibrium. So what it's saying is that once everything balances out, the final temperature of the iron, the metal, should equal the final temperature of the liquid, the water. Wait, let me be very clear. This is TF, water. So this always occurs. So since these two variables are actually equal, we should label them both TF. So this means that temperature final for both should be the 59.5. Now, they normally tell you in the problem as well, but we also need specific heat. Specific heat C of iron is 0.449 joules over grams degrees Celsius. So if these aren't provided for you, you need to know to reference them in like an index or a table in the back of your book. The specific heat of water. Some professors actually expect you to memorize this one or reference a textbook. It's 4.18 joules over grams degrees Celsius. So that's the information you need to know. That's specific heat. That's the capacity for a substance to resist a change in temperature. Yeah, sometimes it's more difficult to heat an object and increase its temperature compared to that of another object, right? So that's the idea behind C. So using this information, let's solve the problem. So now we're going to do Q, the heat of the iron should equal the heat of the water. Now, we can place a negative sign on either side, but let's be very proper. Where should the negative truly go? So if we look back at our given data, I see that the temperature of the iron is 22.7, but then it rises to a final temperature of 59. So that indicates that iron is actually increasing in temperature. It's gaining heat. So this is going to be gaining, which entails I know my water should be losing, but let's just look back. So looking at the temperature of the water, it's initially at 63, but then it drops to 59. So this really is losing. Okay, so now we can set up the problem. So now we're going to use this formula. Heat equals mass times specific heat times temperature change, T final minus T initial. So I'm going to replace each Q with this formula. So again, Q, the heat of iron should be mass iron, specific heat iron, final temperature minus initial. This equals to negative mass water, which is what we're trying to find, specific heat water, temperature change. Substitute the values. Mass of iron was 32.5. Specific heat of iron was 0.449. T final is 59.5 minus our T initial. Good. This equals negative mass H2O, specific heat of water, final temperature minus initial temperature for water. Multiplying everything on the left side gives 537.0 equals negative M. And when I take this product on the right, we get about negative 15.5. Perfect. So at this step here, I'm going to divide both sides by my negative and my negative 15.5. Upon doing so, we get 34.6 grams equals mass H2O. So that's how you solve a specific heat problem for a block of metal placed in a beaker of liquid. We use our specific heat values. They're normally provided in the problem. Otherwise, you reference them in a textbook.